Okay, welcome back student. Today the important topic is conversion of NDFA to DFA. In the last class, in the previous class, we saw what is DFA and we saw what is NDFA. But now we will see uh, uh, conversion from NDFA to DFA. Okay. Why we are doing this means, as in the verses means in the difference, all DFA is a NFA, okay, NFA or NDFA, but not all NDFA is not all NDFA is a DFA. Okay. So, DFA is not a DFA is a NDFA, but NDFA is not a DFA. Because of that, we need to convert from NDFA to DFA. Okay. So, in today's class we will see this and we will see the steps. Okay. First we will see the steps, okay, and we will see one example, okay, and we will do more example on this conversion because this is an important topic. Okay. It will come in the exam, conversion from DFA to conversion of NDFA to DFA. Okay. Now, first thing, in the conversion of NDFA, we need to take x. Let x is equals to qx sigma delta x q0 and fx. So, what is a q? Q is a state of the finite automation and sigma is a alphabets whatever we are going to use. Okay. Delta x, this is a transition function or transition diagram. Okay. This is a delta. Q0 is a initial state and f of x is a final state. Okay. This be an NDFA which accept the language L of x. So, here we are accept the language L x. So, whatever in this we are going to work on it. Okay. So, I am taking x for the NDFA. Okay. Okay. Now, we have to design an equivalent DFA. If you want to convert from NDFA to DFA, that should be a equivalent. So, DFA I am considering y is equals to q of y, okay, is a states, how many states are there, and sigma, how many alphabets are there and how many inputs are there, input symbols, and here delta of y is a transition function or transition table and q0 is the initial state and f of y is a final state of DFA. Okay. And here f of x is a final state of NDFA. Okay. So, this is a basic thing. Okay. We need to take some language, we need to take language, any value, any variable or anything which you need to take all this finite automation inside this x and language we are creating with the name of L of x, and here also we are creating the language of y. Okay. X is a x for NDFA and y is for DFA. Okay. And this should be equivalent, okay, such that L of y is equals to L of x. Fine. So, this is important thing because in DFA and NDFA we have already done this, Q sigma, delta, q0 and final state. Okay. You can go the previous video and see how we did the DFA and NFA. Okay. Now, here the algorithm, in the algorithm we have the two things, input. What are the input we are taking? We are taking the NDFA. Okay. We are taking NDFA is a input. Okay. And what is the output we are getting? We are getting the output an equivalent DFA. Okay, an equivalent DFA. So, this is a algorithm for conversion from NDFA to DFA. So, what is the input? This is a input and this is a output. Okay. This is a output and this is a input. Okay. This is important. Same state, alphabets and delta and q0 and f. So, this is belongs to NDFA and this is belongs to DFA. Okay. So, now next we will see the steps. I hope you clear here, clear about here. So, let us go to the steps. First step of to convert from NDFA to DFA, that is create state table for the given NDFA. Okay. First I will read all the steps, then I will go and step by step we will solve the thing. Okay. In the what is the thing in step 1? Create state table from the given NDFA. Okay. Okay. Next, what is the step 2? Create a blank state table under possible input alphabet for the equivalent DFA. Okay. First we need to state table, you need to create the state table, then you need to create the blank state table under input alphabet for a equivalent DFA. Here we are state table for the DFA and here we are creating the empty state table in DFA. Okay. Next, step 3, mark the start state of the DFA by Q0, same as the NDFA. Okay. So, first step is state table from the given NDFA. Okay. Next, we need to create the DFA blank state table, empty. In the empty, you have to mark the initial state, start state or initial state. Initial state should be same as NDFA. Whatever the NDFA has the initial state, that only you need to make initial state in DFA. Okay. This is a third point. Okay. Now, the fourth point, first find out the combination of states Q0, Q1, so on Qn for each possible input alphabet. So, how many alphabets do you have in the sigma? In the sigma, how many alphabets do you have? You need to find all the combination, find out the combination state from Q0 to Qn and each possible input alphabet. Means Q is like example, if I take the example Q0, Q1. Okay, this is Q and this is a alphabet symbols and this is a states. So, how many states we have? We need to find out the combination of states. Okay, this is also okay. Now, step 5, each time we generate a new DFA state under the input alphabet column, we have to apply step 4 again, otherwise go to the step 6. What is it is telling? Like if it is Q0 to Qn, that means there will be a number of possibilities. So, in the fifth step, it is telling that each time we generate a new DFA, yes, when we make a table, okay. So, every time we will get some different values here. So each time we generate a new DFA state under the input alphabet column, okay, we have to apply step 4 again. This again and again we need to do this. If you don't have a new input alphabet, if you don't have any new alphabet, that means if you finish Q0 and Q1, then if you don't have any new input, that time you need to go to the step 6. Okay. Did you are you clear about this step 5? Once again I will tell you, each time means whatever the combination of the states, like here I have Q0 and Q1. If we finish, if there is no any new new state, or it is not created like Q0 or Q0 Q1, if it is also it is not created, if we have to take the new input alphabet and you need to repeat the step 4. If you don't have any new state, then you need to stop and go to the step 6. Okay. The state which contain any of the function final state of the NDFA are the final state of the equivalent DFA. So what is this? The state which contain any of the final state of DFA are the final state of equivalent DFA. So this is a final step. Okay. Once again I will repeat the step 1, step 2, step 3, step 4 and step 5, step 6. Then we will go to the example and we will solve that. Okay. Okay. Now step 1, create state table from the given NDFA. So first we need to do this. So I am taking the example, this one. Okay. I am taking, this is a example, and what is this? Create state table for the given NDFA, and this is my NDFA. Okay. This is my NDFA. Sorry, I did not make here the initial state. This is the initial state and this is only a final state. Okay. Fine. So here first step is create state table for the given NDFA. So we have created. Okay. So I will go here, here. Fine. So this is a this is a NDFA. Okay. NDFA state table, STAT state table. This is a NDFA state table, and this is a final step. Sorry, I will select the color. This is a final state as well as this is a initial state. Okay. Okay. So now here what it is telling, first create a state table for the given NDFA. Okay. So here when we create this, so here we need like x is equals to q, okay, sigma and delta, okay, comma q0 comma final state. Okay. This is a finite automation, and this is a x and this is also a x. So this is for this table. Okay. Now just go and see here what is q. What is q? Q is q0 comma q1. Okay. Fine. What is sigma? What is sigma? Sigma is 0 1, 0 comma 1. Okay. Next, what is delta? Delta is, this is a delta. Okay. We have a table, transition table. Okay. Next, q0. What is q0? Q0 we have the initial state with this arrow is what is this? Q0. Our initial state is Q0. Okay. Now, F, what is the final state in NDFA? Final state is Q0. Okay, Q0. Okay. So, this is a NDFA state table, and we took the finite automation from there, Q, sigma, delta, Q naught, Fx. So, what is the Q? Q0 and Q1, Q0 and Q1, sigma, okay, here. Now, sigma is 0 and 1, Q0, what is Q0? Initial state is a Q0, and what is the final state? The final state is also a Q0 as per the given table. Okay, as per the given table, this is we got. Okay, and for this you can draw the state diagram also, state graph. This is a, what is the name? This is a state table or transition table. Any one of that you can say, transition table or state table. So, now we need to make the state graph, okay, or state graph, fine, or we can say transition graph. So, here first, what is the Q? We have the Q0 and we have Q1. Okay, this is single circle and this is a single circle. Okay, this is a single circle. Okay, now we need to see sigma 0 1 is there. So, what is the initial state here? I will change the color. What is the initial state here? Initial state is Q0. So, take like this, okay, arrow. And what is the final state? Final state is also a Q0. Okay, this is also a final state. Okay, now you need to go, if Q0, if Q0 is 0, then where it is going? Q0. So, just take like this, 0. Whenever the input is 0, it is going to Q0 only. Okay. Now, Q0 is going to Q1 when the input symbol is input symbol is 1. So, here going here with this, and what is the label? What is the input? 1. It is going from Q0 to Q1, Q0 to Q1 when the input symbol is 1. Okay. Next is Q1. Go to the Q1. We finish this both. Okay. Now, go to the Q1. From the Q1 0, label is 0. So, where it is going? Q1 only. So, here Q1 is 0, then only it is going to Q1. Next, this finish. Next, Q1 to 1. When the input is 1, it is going to Q0 as well as Q1. So, Q1 0 is there, then I am taking 1, and Q1 is going to Q0 when the input symbol is 0. So, this is transition graph. Okay. This is a transition graph. Fine. You can say state graph or transition graph. Fine. So, we created the NDFA state table as well as we saw the all what is the Q, sigma, Q0, F, and we draw the state graph also. Now, we will see the next thing, step 2, create a blank state table under possible input symbol for the equivalent DFA. So, let us draw that. Okay. Here 1, 2, 1. Here okay. So, now here we need to draw the equivalent. What equivalent? Like here, as I told you, q sigma delta q0 fx, the same thing we need to do here. Okay. So, here what are the input symbol equivalent to NDFA? We have 0, sorry, I will take color red, 0, okay, and here 1. The two symbols are like two sigmas are there. Okay. Next, what are the states? Q0 and Q1, Q0 and Q1, sorry. First we need to draw the DFA, DFA empty. This is empty table. Okay. This is a empty table. I will make a correct draw. This and this, this. Okay. I draw the empty table. Okay. So, create a blank state table under possible input alphabet for the equivalent to DFA. So, we created. Now, mark the start state of a DFA by Q0. So, now here we need to make what is the initial state in the NDFA is a Q0. So, you need to take Q0 and this is a initial state. Okay. And what is the sigma? This is 0 and 1. Okay. Now, find out the third step is also finished. We make a initial state. Find out the combination of state Q0. Okay. Q1, Q2, Q3, so on Qn for each possible input alphabet. So, here Q0, okay, Q0 is going to as per this Q0 is 0, where it is going Q0. Okay. So, here make it Q0. Okay.